Good evening, everyone. Welcome to the London School of Economics and Political Science. We are absolutely delighted to have you with us tonight for an exciting event. That's an event that is hosted by STICERD and the Financial Markets Group, and it's the Atkinson Lecture. My name is Professor Camille. I'm a professor in the Department of Economics, and I'm also the director of STICERD, co-hosting this event. Before I introduce our speaker tonight, there are a few housekeeping points that you need to keep in mind. So there is this thing always about planned fire alarm test. I've never fully understood what it is, but should the alarm sound, please note that the fire assembly point is outside the towers. Which towers, nobody knows, but stewards will direct you, okay? Other housekeeping point, please keep your phones on mute or on silent, as always. If you would like to tweet about the event, we have a hashtag. The hashtag is Atkinson Lecture. And finally, we record the event as well, so that it's going to be put online, subject to no technical hiccups, as always. And in terms of the organization, we're going to have a presentation by Andrei. And after that, we are going to leave a little bit of time for Q&A, okay? So now let me introduce our speaker to you tonight. We are absolutely delighted to have with us Andrei Shleifer. He's the John Lobb Professor of Economics at Harvard University, and is quite simply put a giant, a living legend. Is actually the most cited living economist in the world, according to very serious sources like his Wikipedia page. But not only, I checked it up on Repec, it is actually very true. He's the editor of the most highly cited journal in economics, the Quarterly Journal of Economics. He's received many prizes, among others, the John Scott Medal. And all these prizes have rewarded him for his seminal contributions to so many fields, various fields. Let me cite a few: corporate governance, law and economics, institutional economics, development economics. He's actually also a founding father of the field of behavioral finance. And over the past decade, he's worked very extensively with a bunch of co-authors, some of them here, like Pedro, on the economics of what comes to mind, on the economics of memory, of salience, of what we pay attention to and why, what determines the way we form our beliefs and how we use them. That's a whole new field that we can call cognitive economics, and about which he's going to talk to us tonight. We're absolutely delighted to have Andrei with us tonight. The floor is yours, Andrei. Thank you.
Thanks very much. Okay, as soon as I figure out how to move the...
Try the clicker, maybe. Directly.
No?
No. Oh. We have another clicker. Which one?
This one? Okay,
it is
this
working.
working? Okay.
I think this is working.
Okay.
It's the, yeah, right.
Okay. Okay, thank you very much. I'm very happy to be here to talk about some work that Pedro Bordalo and Nicola Giannaioli and I have been doing maybe over the last 10 or 15 years that Camille already described. So maybe I can keep my comments very short, but it's basically work about how we can bring thinking rather than just choice back into economics, and to argue that in fact we need to take the process of thinking, or the process of how people think about problems, represent problems seriously in economics. So let me just introduce the topic. So one of the big organizing ideas in modern economics is the idea that what economists should focus on in what we observe is choice, which is to say we look at choices, we look at how choices change when circumstances change, and then we model behavior as consistent with choice. And the way in which we model behavior is by modeling preferences that are behind the choice. So there is a one-to-one relationship between preferences and choice. And when economists are confronted with puzzling evidence, what we're taught to say, whether it's in behavioral economics or in traditional economics, is that we need to expand the domain or the formulation of preferences. So when people exhibit both risk-taking and risk-averse behavior, we have more complex models of preferences and choice under risk. When people exhibit behavior inconsistent with the standard model of intertemporal choice, we again modify the standard model to make it be beta delta preferences or something else. Whether you think about addiction or or charity or discrimination, the idea is always to modify the utility function. And the same is also true in behavioral economics, or at least behavioral economics of the 80s and 90s, and actually probably even more recently, where again, the idea is to construct exotic preferences that incorporate many considerations in the domain of the utility function and still stay with that standard approach. But the basic tenet of all this is that how people think, or the cognitive processes, are the domain of psychology and not economics. So what I will try to convince you of is that this is over, that if you actually look at the evidence or at the data, the nature of the facts or the findings that we have in economic analysis is such that we can't just fool around with utility functions, that we need to bring into the domain of economics how people think about problems, how they represent problems, what their beliefs are, and perhaps most importantly, where their beliefs come from. And what I will try to argue is we increasingly can do that, both in terms of theory and in terms of measurement. So what is the problem with the standard approach of just focusing on choice or focusing on preferences? And I'll try to illustrate that. First, there is the obvious fact, which I will illustrate, but it's pretty obvious, is that different people solve the same statistical problems with correct answers completely differently. So there's no preferences involved. There is just an enormously heterogeneous set of biases that people seem to exhibit with respect to the same problem. And secondly, and more importantly, is instability, which is if you look at problems that people think about in economics, often very minor changes in how the problem is presented to people or is described leads them in entirely different directions. Problems that are changes that are normatively completely irrelevant to the decision. And so we kind of need to figure out how this works if we are to understand the evidence. We need to understand how people think. So I'm going to talk in part about beliefs, which is in some sense something that's most measurable and we can deal with most easily. But then I'll also talk about attention and memory and the cognitive mechanisms that help us understand how people think. So the model, the depiction of the model that is central to everything we do is this 19th century German illustration of a duck rabbit. So if you look at this picture, you can see that this is the beak of the duck. And this is the eye. So this may look to you like a duck, but you could also think that these are the ears of a rabbit. And this is the mouth of a rabbit. So this is a picture of a rabbit. It's the same picture. but different people see different things. And that's, if you think about many social situations, many economic situations, whether you look at a problem from the point of view of equity or efficiency, whether you think of a bottle of jam that you want to buy as a treat or a staple, how you think about a problem changes how you answer it or how you solve it for the same objective measures of quality or price. So a lot of how we think about the world changes at the point of representation, not at the point of solution. And so this is where we want to go. So let me illustrate this first on the centrality of beliefs, because this is the part, in part, something sponsored by the Financial Markets Group. I want to talk very briefly about the most famous problem in finance, which is the problem of market volatility. I would guess many people here, most people here, have seen the present value formula, that the price of a security in an efficient market is equal to the expected present value of its future dividends. When Robert Shiller addressed this problem, he said, let's, for simplicity, assume that the discount rate is constant. And so that tells you that the price is the expected present value of dividends with the constant discount rates. And then he said, well, let me compute both the left and the right-hand side of this equation. And let me replace the expected dividends with realized dividends and try to understand how prices move compared to the present value of dividends at a constant discount rate. And he said that, look, under the rational expectations assumption, these two sides of the equation should be the same, and therefore they should move in sync with each other. They should be highly correlated. And what he discovered, and I'll show you in a second, is that the left-hand side of the equation, the prices of stocks or other securities are extremely volatile, and that the right-hand side doesn't move at all. And so the question became, how can you think about efficient markets in that context when there is no relationship between the price and the present value of dividends? And so this is what's known as the Shiller puzzle on market volatility. It's a paper that started the field of behavioral finance. Now, if you are an economist trained in the best methods of the field, you look at this equation and you say, where can I stick the utility function to solve this puzzle? So you can't really stick it into the numerator because it's just expectations. So you have to stick it into the denominator. So you create a model of changing discount rates. So when stock prices are high, you say that people are extremely risk-loving, the discounts are low, so the present value of dividends is also high, and conversely. So that is the standard solution to the puzzle. It goes to the utility function. And, there is a famous line by John Cochran who says, exuberance comes at the top of an unprecedented economic expansion, a time when the average investor is, and emphasize the word, surely feeling less risk averse than ever. Now, every time somebody uses the word surely in a sentence, it's almost surely wrong. And this case is no exception. Now, another place you can look at is beliefs. So you can, instead of messing around with the utility functions and looking at the denominator, you can look at the numerator. And what's interesting is, of course, beliefs are measured. They appear in surveys, and you can try to do that. So what happens then? So suppose you replace, you keep the discount rates constant, but instead of using rational expectations of the formula, you'll use measured expectations of future dividends in surveys, and you compare the left side and the right side. this is what you get. So the blue line is the actual stock, the green line, excuse me, is the actual stock prices of the last 40 years. The blue line is the present value formula computed by Shiller with rational expectations. You see there is no volatility. And the red line is what you have, what you get if you plug in the data for expectations about dividend growth. You will notice that the blue line does absolutely nothing, and that the green line and the red line lie exactly on top of each other. Okay, I'm merely illustrating this to make the point that if instead of going to the path of exotic preferences, you went to the path of thinking about beliefs, you can do much better. Just to take this one step further, you can actually ask, are there rational expectations in the stock market? One way we can test for that is we can ask whether forecast errors and beliefs are predictable from the data that decision makers have at the time they form beliefs. In the rational expectation model, forecast errors would be unpredictable. In the data, forecast errors are extremely predictable. When times have been good, forecasts tend to be extremely optimistic, and they tend to be systematically wrong. And not only that, these predictable errors in forecasts also predict future returns. So going from exotic preferences to beliefs gets you pretty far in terms of understanding the data with pretty minimal effort. I should also say, I don't want to dwell on this, is that you can use the same data to explain volatility of investment, to explain the volatility of credit spreads, and so on. Okay, let me change. Why do we need to dig deeper? Why can't we just look at beliefs? Why do we need to look at the foundations of beliefs? I want you to look at two very famous experiments in behavioral economics. And I want to talk about them. Inference problems. These are problems, the tests of the Bayes rule. So the Bose and Ernst problem that goes back to the 1960s says, suppose you have a computer, it chooses, probably didn't say computer in the 1960s, probably said, random choice, but no computers at that time. The computer chooses jar A with a 25% probability, jar B with 75% probability. Jar A contains 80% green marbles, 20% blue marbles. Jar B, the opposite. It has 80% blue marbles, 20% green marbles. Withdraw a marble from a randomly chosen jar. It's green. What do you think is the percent chance it came from jar A? Okay, that's the Bose and Ernst problem. The correct Bayesian answer is 57%. You combine the priors with the likelihoods and you come up with the answer. Here's another problem. Two taxi cab companies, green and blue. 75% of the cabs are blue, 25% are green. A cab was involved in a nighttime accident. A witness later identified the cab as a green cab. The court finds that the witness is able to identify each color correctly about 80% of the time, but confuses us with the other color 20% of the time. What do you think is the percent chance that the errant cab is indeed green, as the witness claimed? If you stare at these two problems for a bit, you will realize that they are identical. The problems of Bayes rates and likelihoods, you combine them using the Bayes rule. The correct answer is 57% for both problems. And these are the two standard problems which people used to study: underreaction, overreaction, and so on. So what do you think happens when you give these problems to experimental subjects? That's what's on the left. You have Bose and Ernst. On the right, you have taxi cabs. The dashed line is the Bayes rule. The black line is the average answer for both of these, and the blue bars are the answers. Okay, so the first thing you notice is that for both problems, there is nobody at the Bayes rule. it's empty. Okay, nobody is doing it. Okay, so everything you've learned at the LSE about the importance of the Bayes rule, you can just forget now. Second thing you notice is that the people are sticking in both problems, either at the base rates or at the likelihood. They're deciding, looking at the problem, which one is the relevant statistic, and then they're anchoring to that statistic. There are very few people. There are some people who are at 50-50, but because they have no clue. But other than that, there is really nobody combining the two pieces of information as they should. Now, what you'll find is that in the Bose and Ernst problems, more people at the base rate and fewer people at the likelihood. People answer the question about Ernst. So if you compute the average, it's a little bit lower than the Bayesian answer. So that's what people in finance call underreaction. But of course, there's no average anything here. It's people at the base rates and people at the likelihood. Okay? If you look at the same problem with different words, many more people are answering about the witness, and the witness being right. So there's a lot of people at the likelihood. There are fewer people at the base rates. Still, that's all where everybody is. There's nobody at the using the Bayes rule. And the average is to the right of the Bayes rule. So we call this overreaction. Again, super stupid, because what matters is the fact that there are people anchoring either to the base rate or to the likelihood. Okay, so like 50 years of behavioral economics that computed the mean in these problems kind of missed the point. Okay, so we need to understand what the hell are people thinking about, not just look at the mean. Why are many of them are thinking about the base rates here, many more are thinking about the likelihood here. And so toward the end of the lecture, I'm going to try to answer that question. But what do we learn from that? What we learn is that we need to figure out how people are thinking about these problems and why with the same numbers and different words, people go in different directions. This is why we need cognitive economics. We need to measure beliefs, and we need to understand how people are doing this. The other point I want to say is there is no stable bias. Some people are at the base rates, other people at the likelihoods. It depends on how they interpret the problem. Many problems that people have thought about look like that. So let me start by talking about a model of beliefs, a simple model of beliefs, and then try to build its foundations, and then talk about attention. So some years ago, we proposed a model of belief formation that deals with some of these issues based on memory, based on selective sampling from memory. And we call this model diagnostic expectations. And the model in its reduced form basically said that people recall outcomes that come to mind, but not randomly, but disproportionately if they are distinctive outcomes in favor of a hypothesis relative to its alternative. So the model of beliefs that captures the data, the density function of beliefs, is proportional to the true density function, but distorted in favor of the states of the world that are most consistent with the data. So in the stock market, for example, normal earnings growth is likely for many firms and is not retrieved, but if you have a firm that's growing rapidly, that's what people think about. What I'll show you is that this model helps us think about many problems in a coherent way. So here's my illustration. Suppose you're trying to estimate the seriousness of MIT students. So you have two probability distributions. The yellow normal distribution is the seriousness of Harvard students. The blue one is the true seriousness of MIT students. And I ask you, how serious are MIT students? Well, what you might want to think about is if you look at the most serious people, they're disproportionately from MIT. The likelihood ratio is very high here. If you think of the least serious people, they're disproportionately from Harvard. So in estimating the seriousness of MIT students, you're going to put excess weights on the parts of the distribution where the MIT students are most different, which is to say most serious, which is to say the right tail. So the distribution you may believe in will be something for MIT students, it would be something like the red normal curve, which is to say you'd shift to the right because you'll overweight the most serious types in the MIT distribution. Those are the types that come to mind. Those are the things that you'll think about when you think about MIT students. You'll think about the most serious ones. Now, this turns out to be a pretty simple idea, but it turns out that you could use it in macroeconomics and finance in thinking about discrimination. Let me just give you an illustration. And again, you don't need preferences for any of this. So suppose I asked you, I told you a person is Irish, what are the chances they have red hair? We've done this experiment many times. People always give you answers like 20 or 30%. This is the true distribution of hair color. So the red hair color is 10% of the Irish have red hair. Almost nobody in the rest of the world has red hair. Most of the people in the world have either light brown or dark hair. And in fact, even among the Irish, light brown and dark hair are the most common. Yet people systematically overweight the likelihood of red hair conditional on a person being Irish. Well, it's the same thing as with the MIT students, which is to say that the distinctive hair type for the Irish is red. That's who comes to mind. And that's who gets overweighted at decisions. And in fact, you can estimate using survey data, the equation that I've shown you, you could estimate theta, and it works extremely well in describing the data. This is something more serious. Suppose you look at across firms at true growth rates among, let's say, the highest growth decile firms from the past. This is the blue line, and the average firm, which is the orange line. And if you ask, what would be the believed among the analysts probability distribution? Well, if you again think about for the most rapidly growing firms, what comes to mind when you estimate their future prospects is precisely these extremely high growth rates. You would say that in the data, the believed probability distribution is going to be a shift of the blue line to the right, because this is where the likelihood ratios are the highest. That's what, in fact, you find in the data, and you also find that these firms are the most overvalued and their returns are predictably low. So this model of firms are stereotyped just like the Irish are stereotyped, and so on. You find these things in other domains as well, which is to say, when people think about representative types or most different types when they make estimates. This is a pretty remarkable picture of polarization between Democrats and Republicans in the United States. So these are different dots here are different issues. On the x-axis, you have the true difference in beliefs across these issues between conservatives and liberals. On the y-axis, you have the belief difference in beliefs among conservatives and liberals. And in basically every single instance, it doesn't matter whom you ask. Republicans and Democrats have the same view. They're both wrong in exactly the same way, which is that they think that the beliefs are much more polarized than they really are. Again, stereotypes is what matters and shapes beliefs. The next one is from a totally different context, from a recent paper by Leo Burstein and others on beliefs of women and men about human rights and affirmative action and basic rights for women. And what you find is that in all instances, the perceived difference in beliefs is higher among men and women, is higher than the true difference in beliefs. So just to summarize stereotypes, in standard models, discrimination is due to preferences. If you think about it, that really doesn't make a whole lot of sense because we see a lot of stereotyping and discrimination in contexts where preferences really don't enter. But what I've tried to suggest to you is basic cognitive processes of selective retrieval or recall of instances of experiences that are most distinctive or most similar to the hypothesis actually accounts for the data and beliefs in the discrimination context, in finance, in political context, and matters for how teachers evaluate students. It matters for how people write recommendations, and so on. It's just a basic cognitive process. Now, once I've shown you a reduced form, can I prove to you that this is a basic cognitive process? You know, how would I do it? Well, you can try to do it with a controlled experiment. So I'm trying to get away from every loaded issue, you know, gender, color of hair color of the Irish, stocks, and we're going to have a purely abstract experiment. So here is what we do. We show participants a random sequence of 40 images. 10 of them are orange words, 10 of them are orange numbers, and 20 are blue items. Okay? And after a brief delay, we ask them, a randomly drawn image is orange. What is the probability it's a word? So the correct answer is 1/2. So I'm going to now replicate exactly the situation that I showed you with stocks and that I've shown you with red-haired Irish and so on. I have two treatments. One is all blue images are numbers. And two, all blue images are words. Now, this is irrelevant information because the question is about the orange images. Shouldn't affect your answer. But if I'm asking you about an orange word, when the blue images are words, they're going to mess with you, with your recall, and make it more difficult. When the blue images are numbers, they're completely irrelevant. This is what happens in the data. This is the estimated probability that conditional on the image being orange, that it's a word. When the blue images are numbers and there is no interference, I have an estimate that's actually higher than the truth, it's 55%. You also have much higher rate of recall of the orange words if you ask them to remember. In the treatment, when the blue images are all words, so they interfere with the recall of orange words, you have much, much lower, huge underestimation of the probability that an orange object is a word. Okay, so I have now linked the basic ideas of how memory works, the idea of interference in the recollection and the idea of selective recall to the kind of framework of diagnostic expectations that I proposed and to the empirical evidence. And what I want to stress to you is we have theory, we have measurement, because we can ask people what they remember, and we have predictions for the field data. So you can actually do the whole chain of analysis from cognitive foundations to how people think about the problem to what you see in field data, which is very, very important to us. This is just to show that recollection of probability are the same. Let me do one last memory experiment. So one prediction of this way of thinking about it is that you can change people's beliefs by getting them to think or to retrieve different experiences. And that you will change their beliefs more strongly if, in fact, the experiences you encourage them to retrieve, you cue them to retrieve, are more similar to the object, to the event that they're trying to predict. So what we did is we asked a bunch of people what they think is the probability of a cyber attack in the United States in the next 5 years. To be clear, nobody knows what a cyber attack is. And so the estimates are all over the place. But then we started asking people to recall what a cyber attack would be similar to. And in some instances, we cued them to think about ID theft, financial troubles, loss of a loved one, etc. And what you discover is, of course, they are totally irrelevant experiences for the probability of a cyber attack, but they get them thinking about similar issues. And what you discover, this is just to generalize this, is that if people have an experience which they describe as similar, that raises their estimate of the likelihood of a cyber attack. If you prime them to think about something that they think is similar, that raises their estimates of the probability of a cyber attack. And in fact, not only that, even the interference stuff that I've showed you with blue and orange shapes works out here, which is there is interference between primed and other lived experiences. So what is it? Where does this take us? I started with saying that beliefs exhibit remarkable disagreement and instability, sensitivity to irrelevant changes in the problem. And that seems to be true in the data. It also seems to be the case that you can use beliefs to explain a lot of facts without assuming exotic utility. What is also important is that, the psychology of memory is pretty well established, and we know what we need to measure. We know what we need to look at in order to understand how beliefs are formed. And so, again, what I want to stress is that there is a chain going from basic science to theory to measurement if you go in this direction. Okay, let me switch gears and talk about something very different and come back to balls and urns, which is the role of attention. So attention, again, in psychology, is taking possession by the mind of one out of what seems several simultaneously possible trains of thought. Focalization is of its essence, which is James defined attention as trimming some of the information that you have when you think about a complex problem and focusing on the rest. We focused in our work on kind of basic bottom-up attention, which is what captures your imagination, what you think about. And it turns out that this is very helpful to thinking about statistical problems. So when I want to illustrate the idea of attention from, starting with the first principles, which is one of the most beautiful problems in decision theory and economics, which is the LA paradox. For those of you who have seen it, the LA paradox refers to the following phenomenon. I ask you to choose between two lotteries. with a common alternative, which is this number Z, which comes with 66% probability in both of them. And the prediction of standard decision theory is that your answer should be independent of Z. So no matter what Z is, this is independent of a relevant alternative. It's a common feature of both logics. And what Landais famously tricked some of the most famous economists in the world with is to say, well, let's suppose that Z is equal to 2400. So then the right lottery becomes 2400 for sure, and the left lottery becomes this. And it has a 0 with this 1% probability. And lo and behold, most people in this situation choose the safe lottery, excuse me. And the reason people have wondered about this, but what you'll notice is that the risky lottery here has this terrible outcome of 0, which draws your attention and probably receives disproportionate weight. When Z is equal to 0 instead of 2400, then the two lotteries become both risky. They have the same downside of 0, but one has an upside of 2500 with a lower probability, and the other has an upside of 2400. So the payoff that stands out is the upside of this lottery. And then you see people switching. Okay, so the Landais paradox, even though people try to explain it in any ways, and you can actually trace the attention patterns in it, is actually a story about which one of the payoffs sticks out, which feature of the problem sticks out. And we've run many experiments, other people have run experiments. Turns out that like bringing attention into this problem works much better than doing many other things. So the question then, for the cognitive economics is, if we want to understand cognition, some of what we need to understand is memory, but what we also need to understand is attention and how we can change attention. So let me go back to balls and urns and taxi cabs. And what I'm going to try to ask myself is, well, one can conjecture that the people who answer with the base rate, especially since the question in the balls and urns problem was about the urns, are probably excessively focused on the information they have about urns and neglect the information about the color of the ball. Whereas people who respond with likelihood are probably excessively focused on the color of the ball and don't pay attention to the base rates about the urns. In the taxi cabs problem, it may very well be the opposite, that the people who think about the witness think about the likelihood that the witness is correct, whereas the people who think about the percentages of cabs of different colors are thinking about the base rates. And there are many more people focused on the witness than on the base rates. So how would you test this conjecture that attention is at the heart of this switch in how people solve the problem? Well, one thing you can do is to manipulate attention. So what if in balls and urns, can we get a little bit more people to focus on the likelihood, or in taxi cabs, can we get a few more people to focus on the base rate? So let me show you how this works. So if you think about the inference problems, there are kind of 3 steps that people may be thinking about. There is the selection of an urn of a cab company. This is base rate. Drawing a signal, whether it's the color of a ball or a witness report. And maybe the other relevant thing is matching between the signal and the hypothesis. That is to say, is green ball mostly from green urn? Was the cab green as reported? That is to say, the likelihood. And so the conjecture is that people use the statistics that their attention is drawn to, how they interpret the problem, how they represent the problem, changes their attention and the answer. So what we did is we asked people after they solved this problem, what were they thinking about? Both in a structured way and an unstructured way. And lo and behold, what you find is that people's responses as to what they thought was the piece of data they paid attention to and their answer to the problem are pretty highly correlated. There is a direct match between attention and the answer to the problem. But we can do better. So here are two nice experiments, and I hope if you know the pecan rule, this is what you remember coming out of this lecture. Suppose I try to cabify balls and urns, which is to say, I'm going to take the balls and urns problem and make it sound like the taxi cab problem. I'm not going to change any of the numbers. I'm just going to change what I say about the problem or how I present it. So we're going to say, describe the data generating process. I say there are two urns, green and blue, with colored balls that I report the base rates. Out of 100 draws from an urn, the ball drawn matches the urn color 80% of the time, as in the witness is right 80% of the time, and the other color otherwise. The drawn ball is green. Well, what is the probability that it comes from the mostly green urn? This is the original balls and urns I showed you. These are the original taxi cabs that I showed you. These are the cabified balls and urns. They look exactly like cabs. Okay, so by manipulating which feature of the problem you think is relevant, I can get you to solve balls and urns exactly like you solve taxi cabs, or very close. I didn't change any of the numbers. There is no base rule here, God forbid. There is no manipulation, standard manipulation, distortion of the base rule, because it doesn't do anything for you. Just shift your attention to thinking that, as in the witness problem, that the match is the relevant feature, and you go all the way to likelihoods. Not only that, if I do the elicitation of attention, many people, instead of telling me that they've paid attention to the base rates, now say that they paid attention to the match or to the likelihood. So attention and the answers follow each other. What about going in the opposite direction? I keep all the numbers the same. A cab was involved in a nighttime accident. A witness later identified the cab as green. I say the court found that the witness was very unreliable. Okay, that's all I add to the description. The numbers are all the same. And it identifies the color of the cab correctly 80% of the time. These are old balls and urns. These are old taxi cabs. Here's undermined witness. It goes a good part of the way, not all the way, toward balls and urns. Okay, so what it tells us is how the presentation of the problem changes what people think about, which features of the problem they think about, and which features of the problem they ignore, radically changes their answers. And again, one can do theory, one can do measurement of attention, and one can understand how this process works. And attention, again, follows the answers. So let me summarize and try to finish. So selective attention shows how people fail to aggregate information. It unifies many biases, and it helps us think about heterogeneity and instability. It gives us a totally new way of thinking about over and under reaction to information, because rather than thinking of everybody doing the same thing and putting distorted weight on different bits of data, shows that what happens is that some people just switch their focus of attention, and it tells us how mechanically over and under reaction works. By the way, in all these problems, people who represent the problem correctly, which is to say, they tell us that they're thinking about both the base rates and the likelihoods, those people tend to solve the problem correctly. So the issue is not inability to solve, it's the incorrect representation. And so we're beginning to understand the features of what draws attention and how it makes it different for the answers. So let me conclude and then open to questions. I think we have growing evidence on beliefs, evidence from experiments, evidence on disagreement, evidence on conflict, that in order to understand individual behavior, we need to appreciate that different people think about problems in very different ways, that they're not combine all the available information, but that they select information and use it to solve the problems. I should say that it's fashionable to say that it's motivated beliefs, that people have strong priors about what the right answer is, and that they select information to confirm their priors. What I've shown you is a variety of experiments in which there is no motivation, there is no right and wrong from the point of view of the decision maker, other than the accuracy. So maybe motivated beliefs are important in some situations, but it's definitely not a core cognitive principle. But what I mostly wanted to convince you of is two things. One is what I call the chain, which is to say that this approach to solving or modeling economic choices and decisions actually starts with theory, starts with science, then allows you to measure things step by step, from memory to attention to beliefs to choices. And so in that respect, it's much more scientific than standard economics, which just jumps from choice or from utility to choice without looking at any of the intermediate steps. The other point that I want to make is that this is not just about cute experiments, but it appears that very, very rapidly over the last 5 or 10 years, in more and more domains of economics, people have tried to use or to apply this kind of formula or this approach, and with very successful empirical results. That is to say that, thinking about macro financial stability, thinking about stock returns, thinking about discrimination and group disagreement, thinking about information provision, probably many more scenarios that actually, starting from basic principles of memory and attention, mostly memory, and then tracing how people think about the problem, turns out to be a very productive way. One of my favorite areas, and this is actually one of the places where we started many years ago, is advertising, which kind of illustrates these ideas very, very clearly, which is what advertising does, is to try to get you to think about your choice or about a problem in one way rather than others. Okay, this is all about changing your beliefs about a product. So one of the famous ads, Marlboro cigarettes are macho and masculine, but one of the most famous examples, which has actually been used for decades, is this Avis rent-a-car ad that says Avis is only number 2 in rent-a-cars, so we try harder. So rather than thinking of Avis as a loser that fails to beat Hertz, people think of it as an underdog that tries harder. Again, didn't persuade everybody. In fact, we've run experiments that show that it didn't persuade everybody. Some people think, in fact, learn from this ad that Avis is a loser, but enough people think of it, of the ad as Avis being an underdog, that it actually works. So we're back to duck rabbit. We're back to the idea that different people think about the same problem, and we've looked at objective statistical problems, let alone complex political problems. Different people think about them in different ways based on their experiences, based on what they know, based on their attention, which is sometimes pretty random, that is what shapes how they think about the problems and therefore how they solve them. So thank you very much. I hope there is some time for questions.
Thank you very much, Andrei. So we have probably 10 minutes for Q&As. I'm going to ask you to raise your hand if you want to ask a question, and Stuart can give you a microphone. And as always, I'm going to ask you to keep your questions to the point, short and to the point. And we actually need to take 2 online questions as well. Okay, excellent. Anyone? Yes.
Thank you. Concerning the LA paradox, by the way, thank you for the talk. I find it very inspiring. One way to explain the LA paradox is also to use rank-dependent utility, for example. But in your talk, you say that we shouldn't look at fancy ways of utility function. So would you then disregard that stream of literature about rank-dependent utility, and instead should we focus more on what you proposed today?
Look, I definitely would say that this is a more promising way to go, what I've described to you. I think one of the things that we want to do in this line of work is to have some kind of unification of very disparate phenomena. And risk-taking is just one of many. There are pretty broad principles of memory and attention that apply across very different settings. So LA paradox is just one of them. I don't know how rank-dependent utility actually does with correlated LA, which I didn't talk about, but it was on the slides. But it seems to be that in terms of how much different stuff one can explain, I would probably go with what I've just described to you.
Thank you. Yes, over there.
Hi, I'm a third-year finance student. I'm actually presenting one of your papers on Monday on the one you wrote in '98 on sentiment. When I presented your ex-Capen paper a few weeks ago. And I was just wondering, since like '98, 2015, are your beliefs very much similar to what they were sort of then, or incorporating things like this? How's it sort of changed, you and your colleagues, I guess?
So that's actually a very good question. And yes, my beliefs have changed, and this is following very precise way, which is that the paper you referred to from 1998 assumes very, very rigid and uncontingent behavior that everybody, belief formation that everybody shares. So that's just wrong. And so what I've tried to say is that there are fundamental differences which we can trace in how different people interpret information and form beliefs. And so to the extent that we are moving toward more realistic models, that has to be the place rather than the kind of rigidity that we had 25 years ago. In fact, when I showed you the taxi cabs and the Pauls and Earns example, that by itself is evidence that how we model things in that paper is incorrect.
Sorry, yeah, as the mic gets there, maybe we can take the questions from online. So Kanish is going to essentially be the messenger here.
Yeah, so one question from Darren, who's a high school student applying for economics undergrad, is asking, in what ways can cognitive economics help explain the persistence of certain market anomalies? Should I do 2 in one go, or should I just...
Yes,
and then someone else asks,
for you to elaborate a little bit more on the sector of advertising and how cognitive economics you see intersecting with that. For example, what kind of experiments you're imagining, or what kind of examples?
So let me, I can't quite understand the first question, so let me answer the second. As I said, let's go back to the standard of economics of advertising is that, going back to Stigler, is that advertising is provision of hard information about quality and price. So, the classic idea of advertising is you open your Wednesday newspaper and it tells you what's on sale at your supermarket, and that's information, and you update whether you go, what to buy, and so on. In the 90s or 80s, maybe, economists kind of realized that a lot of advertising, whether you think about the ad that I've just shown you for Avis Rent a Car, or the ad for Marlboro cigarettes, or many of the other famous ads, in fact, don't convey very much information about objective price or quality of the product at all. And so then you had kind of a new generation of advertising theories. One of the dumbest in the history of economics was proposed by Paul Milgram and somebody else, that said that advertising is dissipative signaling. So you just want to show that you want to waste the money. And the problem with that, of course, is that advertising is extremely purposeful, and people work and try to understand the content or develop the content extremely hard. So where this goes with advertising is the fact, what seems to be a self-evident fact, and it's also true in the data, is that much of the advertising is not provision of hard information at all, but rather a suggestion of how you think about different products. So Marlboro cigarettes were introduced at the time when men did not smoke filtered cigarettes. So it was the first filtered cigarette for men. And so Philip Morris wanted to tell people that smoking Marlboros is macho. And so they produced an ad. If you look at these ads, the only information that they contain is they tell you that smoking kills, the only objective information. But other than that, it's just a picture of a cowboy. If you look at the advertising, also they want you to think about a particular feature, which is not an objective feature of Marlboro cigarettes. And, that worked. It's worth about 25% of the world cigarette market. The same with this ad that I've just shown you. Again, there's no hard information here. The only hard information in this ad is negative, because it says that they're number 2, okay, that they're not number 1. But they want to twist the correct information to represent themselves as an underdog. There is no evidence that they're an underdog. There's no hard data or anything else other than the statement that they're an underdog. But it obviously is effective, or has been effective, with a large number of people. Next time you see ads, you will see that it's, again, always about representation, often about representation, not always, not surely, but often about representation, in the sense that the advertiser or the persuader wants you to think about a particular issue in a particular way. If you think about political speech, it's exactly the same. If you think about legal persuasion, it's exactly the same. There are always two sides, multiple sides, or multiple features of a problem. And the persuader wants you to think about one feature and not to think about the others because of interference. So persuasion and advertising are very, very intimately related to the things that I've talked about today.
We have one question here, and maybe we can, after that, take the two in the back.
Hi, I'm Raphael. Thank you for the talk. I was just wondering if, working within the diagnostic expectations model, if the estimate for theta might sometimes be a little biased upward, because, maybe, for example, I might be more likely to ascertain the group of an individual who has a more salient trait. So for example, if someone is more serious, I might be more likely to ask, why are you so serious when you go to school? If someone has red hair, I might want to ask about their ethnicity, whereas if they have light or dark hair or something, I might not really care, right? So then maybe this, the result of the higher likelihood or the overreaction might partly be due to just having failed to kind of get to the full distribution.
I think what you said is exactly right. It's 100% right. And the point is that memory is selective. It doesn't sample the whole distribution. It samples things that are most similar to the hypothesis that you're trying to evaluate. But most importantly, the selection is governed to a very large extent by interference, which biases your retrieval towards selective types. So you're exactly right, which is to say that the estimates of the seriousness of MIT students fail to retrieve the whole distribution, which has, a huge number of people at the center and a huge left tail, because you're oversampling distinctive types rather than the whole distribution. So what gives you diagnostic expectations and many other things I talked about is precisely the selectivity of memory. It's precisely the fact that we're not automatically sampling the whole distribution. And the point here is how we retrieve things is not volitional, it's automatic. This is how we're wired. We are wired to disproportionately retrieve distinctive types.
I was just asking if it was possible, even under kind of perfect memory, that we could observe some degree of this effect, because I don't always ask, right, whether someone is what school somebody's from. Right? I don't care to ask unless you have a unique trait.
So you're saying that, well, but it's a bit circular. I mean, MIT has a reputation for being excessively serious and its students for being excessively serious. And that trait gets associated with MIT. And that, of course, only reinforces the retrieval of the instances of very serious MIT students. So the stereotype itself may further reinforce what we look for.
Right. Can I just finish this?
Yeah, I think if you don't mind, we have two more questions, only 2-3 minutes left. So if you don't mind, we're gonna.
That's all right.
Sorry about that. Yes, in the back.
Thank you, Professor, for your very inspiring talk. My question is that, and like you said, in behavioral economics, what we typically do is that we do those little ad hoc modification on a standard model. Do you think in the case of cognitive economics, after removing towards the things that are typically underappreciated in standard model, like attention or memory and everything, do you think there's a potential in cognitive economics to build its own overarching theory and kind of separate from the standard economics? Do you think we have the potential to do that?
Okay, so let me say this. From the point of view of science, we understand memory much better than we understand attention. So there is a question about, when you say building an overarching theory, there are scientific pieces of it that we don't have. So that kind of slows us down. I think the most important feature of thinking about cognition is what I started with, which is there is a lot more heterogeneity in the world in what individuals believe, and their beliefs in many instances are quite fragile. So yes, I think we can develop such a theory in a pretty systematic way, maybe over the next 5 to 10 years, but it's going to be an essential feature of it. that the world is going to be a lot less mechanical than we think today.
That was, and last question.
Yeah, I was wondering how the results you'd found would change in a small or large group setting. In particular, you mentioned coming to the right model of the problem is very important. And we saw how different people came to model different variables of the problem. So I would imagine that in a larger group setting, more of the variables of the problem would be accounted for, and thus you'd be more likely to get to a more correct answer. Do you think that in a group setting, your results would hold? And as you grow the group larger, do your results hold less?
It's a beautiful question, and people are working on it, not us, other people. And it's much more interesting than one would think and complicated. When you think about persuasion, first of all, you need to start with persuasion between two people rather than big groups. And what you find, to the extent that people have started running experiments on persuasion, is that there are social factors in persuasion, which also are relevant for large groups, which is that there is a huge homophily in there, which is to say that people are more persuaded, keeping the argument constant, by people like themselves than by people who are different. The second point is that even in two-person persuasion situations, you find that people are more likely to be persuaded if the persuader is correct in an objective setting than if the persuader is wrong, but it's very far from perfect in terms of capacity to persuade. I think that in large group settings, you have both of these forces coming to play a role, which is to say that, the persuasive arguments, as in what I've just said, are going to be the ones that resonate, and those are not necessarily, which is to say, are consistent with the experiences that I retrieve, and those are not necessarily the right ones. And a lot of it is going to depend on even in a large group setting, on the homophily of the group. So the point of it is to say it's a fantastic problem, and it's a totally open problem, and people are just beginning to look at it. But the good news is they're looking at it in the right way rather than in the neoclassical way, which has gotten us pretty much nowhere.
Any other question? If not, Nava wants to ask a question. Come on, Nava.
So just on.
And take the mic maybe so that everybody can hear you.
Nava always has the last word.
I have to have the aspects of attention that might be more important. You didn't touch on emotion, but that how do you see that as affecting retrieval in a biased way, potentially?
Okay, so I think we know that there is science that links emotion to retrieval. Some of the science which you have contributed to is trauma interferes with retrieval very, very sharply, which is to say it blocks retrieval of everything but the experience of the trauma. I think that the fair answer is that emotion is probably right on the frontier of what people want to think about in this area. But like persuasion, it's wide open. I'm very excited that people in the room are thinking forward, not backward. It's very good news.
Excellent. Actually, if I may, I'm gonna actually steal the last word. I do want to ask you a question, maybe as a parent, as a father. I'm quite curious to know how you think that your work is also potentially helping us teach ourselves and also our kids how to resist persuasion or cognitive manipulation. How would you say that your work is potentially helping us in maybe just by awareness, or maybe also by direct intervention to constrain the elements of manipulation? How would you say that we can essentially help our kids resist the most obvious manipulation to cognitive?
Again, I mean, obviously, I'm not an expert, very far from an expert, very far from an expert. But again, it seems to me that the things we understand about memory is that people retrieve events that are similar to the situations that they're facing. They retrieve salient events with a greater probability, whether salience is correlated with emotion, whether it's correlated with something else. And so I would think that from first principles, and again, knowing nothing, to the extent that children have in their database experiences that they can retrieve, that it will actually subsequently lead them to good decisions as opposed to bad decisions. That's mechanically probably a good way to do it, but who knows?
Excellent. I think you will join me in thanking Andrei for this fascinating lecture.